So now the next kind of chemical reaction what could take place will be exactly the opposite of direct combination, that is called as decomposition. So the next one over here is decomposition. As the word says, composition was combining, decomposition is separating. So that's why when you have got certain thing wherein AB on reaction becomes A plus B, that means it separates into two different elements or compounds or dono compound, then it is called as a decomposition reaction. It is going to be the same way as in case of direct combination. Direct combination में क्या था? Two elements giving me a compound. Similarly here, a compound giving me two elements. That is possible. A compound giving me a compound and an element. Possible. A compound giving me a compound and a compound. Again possible. So there could be all the three conditions can be there, that a compound giving me two new elements, a compound giving me a new compound and an element, and a compound giving me two different compounds. So in this way, the same as what we had in case of direct combination, we have got such kind of reactions in decomposition also. Now the decomposition reaction, the major thing about decomposition reaction is there are certain standard reactions which takes place when you are going to decompose certain kinds of salts or certain kinds of compounds. Like if I have an oxide, then what will happen when an oxide is heated? So we can say that decomposition, when it is going to be done with the help of heat, is called as thermal decomposition. So when heat is going to be given to a particular compound and that compound splits into two, then we call that kind of decomposition as thermal decomposition. Now we are going to have some standard kind of decompositions what takes place for the oxides, hydroxides, then we have got over here carbonates, nitrates. Okay, so these are the four kinds of compounds what we are going to see now for the thermal decomposition. Now for this, we also need to know one more important thing, and that is called as the reactivity series of metals. It is metallic reactivity series, so it is activity series, metal activity series. What is metal activity series? It is basically the names of the elements which are placed in the descending order of their reaction capacity. So that means the one which is at the top is highly reactive. The one at the bottom is less reactive or very less reactive. So accordingly, that complete list of the elements what we write over there, of course, they're not complete, we have all the metals which are present, but the normal ones which are very commonly in progress. So the one which is going to be a very common kind of elements, those elements ka list hai. So these elements ka list is this way. The first one is K, that is potassium. The next is sodium, Na, then calcium, okay, then it is magnesium, uske baad Al, Zn, okay, then Fe, Pb, then H, then Cu, okay, then Ag, Hg, and Pt, and Au. So we'll just read out the thing. Potassium, sodium, calcium, magnesium, aluminium, zinc, iron, lead, hydrogen, copper, mercury, silver, platinum, gold. This is the reactivity series. That means that potassium is the one which is highly reactive. The strongest. Potassium, strongest. Like hydrogen over here, weaker one. Platinum and gold, weakest. Almost non-reacting. And that is why the jewelry are made of platinum and gold, because platinum gold react नहीं करेंगे, इसीलिए वो pure form में रहेंगे. That's why platinum gold the last, potassium sodium the first. There is also a way to remember this thing to a certain extent. I have not made completely नहीं है, but थोड़ा बहुत यहाँ तक learn कर सकते हो. That is KNA is nothing but Katrina. Okay, Katrina, कार मांगे. Which are the car तो मांग कौन से कार मांग रही है वो? Alto, फिर उससे बचा था Zen, then Ferrari, Porsche. इतना हाइड्रोजन इस तक लर्न करने, हाइड्रोजन उसके बाद आ जाएगा, then उसके बाद लर्न करना इजी. So this is what is required, that you need to know the reactivity series. तो हम लोग इतना तो याद कर ही सकते हैं कि कैटरीना, कार मांगे, Alto, Zen, Ferrari, Porsche. So this gives you the idea that what are the ones which are there, because this is going to be very useful even in the next part of the chapter, that is going to be the displacement reactions and the double displacement reaction. So learning this by heart is a must. It is a must to learn this thing by heart. So up to hydrogen we can learn it very easily, क्योंकि वही ज़्यादा करके use होता है. उसके बाद में जितने हैं, that is like okay, they are not used so much. So that's why Katrina, कार मांगे, Alto, Zen, Ferrari, Porsche. Katrina, कार मांगे, Alto, Zen, Ferrari, Porsche. Hydrogen, तो that is, you can brief it as it is. So from hydrogen you can learn it in a different manner. Right. So what we will be having is the oxides of these metals, hydroxide of these metals, the carbonates of these metals, and the nitrates of these metals. ये सभी का जब thermal decomposition होगा तो क्या होगा? That is the question what we are going to see right now. So the first thing over here is, let's talk about the metal series with oxides. It is seen that the oxides of each and every metal, okay, oxides of each and every metal till Cu, till copper, are stable. That means if I take over here K2O, yeah, I take CuO, means all the one between this to this, jitne bhi oxides hai, they are stable. What do you mean by stable? That means even if you heat it, they are not going to decompose. So the decomposition is not going to take place for oxides of K, Na, Ca, Mg, Al, Zn, Fe, Pb का oxides को कुछ नहीं होने वाला. Hydrogen and even water, when we heat it, does it turn into hydrogen, oxygen? No. So these are stable. But उसके नीचे वाला है, like अगर मैंने mercuric oxide लिया HgO, on heating it becomes Hg plus O2. So this is important, that if I am going to heat an oxide of anything below this, normally ये तो oxide form करेगा ही नहीं, Ag, Pt, Au तो oxide form ही नहीं करेगा, but mercury फिर भी थोड़ा बहुत possibility है form करेगा. तो अगर वो form करता है, if it is forming an oxide, then the oxide of Hg, that is mercuric oxide, is going to form into mercury plus oxygen. So oxides of mercury will give you metal plus oxygen. First thing. Next we see the hydroxides. So we now see the hydroxides of the things over here. So first over here is K and Na. So this was about the oxide. Now about Ka hydroxide is stable. So potassium and sodium का hydroxide यानी KOH और NaOH को हम लोग कितना भी हीट करें वो डिसोशिएट नहीं होगा. it is not going to decompose at all. KOH, AOH and NaOH on heating is not going to decompose. It is absolutely stable. But after that, that is from calcium to copper, these ones are unstable. So what will they give? They will give such way that metallic hydroxide on heating will give metallic oxide plus water. Okay, metallic hydroxide will give metallic oxide plus water. Let's take an example. We take an example of CaOH twice. Will give me CaO plus H2O. Samjha? So metallic hydroxide will give you metallic oxide plus water. So any hydroxide from year to year is going to give me metallic oxide plus water. Like take PbOH twice, PbO plus H2O. CuOH twice, Cu plus H2O. Got it? So in this way, any metallic oxide from Ca to Cu will be giving me metallic oxide plus hydrogen. Now, same thing also happens for this one, HgOH twice. This HgOH twice, you will find that they normally do not form a hydroxide. They will rarely form a hydroxide. But by chance agar kar bhi liya, it will give me mercury plus oxygen plus water. Because here HgO cannot be formed, because HgO form ho bhi gaya to ye ho jayega. If I form HgO over here, HgO or further heating becomes Hg plus O2. So definitely what will happen is I am going to get over here Hg plus H2O plus O2. Okay, but normally mercury और वो सब जो है ये वाले पार्ट है वो हाइड्रोक्साइड फॉर्म करते ही नहीं है. So there is no possibility of them forming into hydroxide at all. So that is why we are having over here that right from Ca to Cu, it is going to give me metallic oxide plus water. Next what we are going to see is that of the, so we saw this and we saw this, now we see the carbonates and nitrates. So first we see is the carbonates. So in case of carbonates, again Ka stable. So carbonates of K and Na are stable. Potassium carbonates K2CO3, Na2CO3 both कितना भी हीट कर लो कुछ नहीं होगा. So KNO3 or K2NO3 or Na2NO3, the CO3 is not going to give you any kind of decomposition at all. But once we start with Ca again to Cu. So from Ca to Cu, what is going to happen is metallic carbonate on heating will give me metallic oxide plus carbon dioxide. So carbonates give me metallic oxides plus carbon dioxide. Example, we can take over here MgCO3 will give me MgO plus CO2. Okay, so you can see that whenever you take any kind of metallic carbonate over here from any of these, it is going to be on heating. So I am going to heat this thing, and on heating I am going to get over here metallic oxide, that is MgO plus CO2 as the resultant over here. So carbonates on heating gives you carbon dioxide. Very very important to remember throughout 10th standard तक ये बहुत time करना है, इसीलिए it's very very important to learn it. Learning this part, learning all these parts are very very important. See, ये particular chapter के point of view से this is not so important, but because here we just need to understand what is the decomposition reaction. But as a chemistry point of view, in point of view of chemistry, because you will be also be having certain practicals in your schools. So practicals के अंदर क्या जो भी questions है वो भी board में पूछते हैं, तो वो practical में ये सब कुछ काम में आता है. That what will happen when a carbonate is heated? Carbonate whenever it is, it's going to give you carbon dioxide gas. The gas evolved when carbonate is heated is carbon dioxide. Clear? Right. Same way, what will happen to Hg? The HgCO3, when HgCO3 is going to be heated, it is going to be this way, that it will give you Hg plus CO2 plus O2. Why is it so? Because Hg, even it is forming HgO, HgO on heating will become Hg plus O2. Got it? HgO itself is unstable. Here you are getting MgO which is stable. Because it was stable, it did not decompose further. But HgO is unstable. So the moment you are going to get HgO here, it becomes Hg plus O2. Hence you are going to get Hg plus CO2 plus O2 as the reaction when mercuric carbonate is heated to give you mercury plus carbon dioxide plus oxygen. Clear? That was about the carbonates. Now we come to the last one, that is nitrates. So the last one over here is the nitrate. Now in case of nitrates, now this is the first time that the KNO3 and NaNO3 are not stable. These are the first time that potassium and sodium nitrates are the one which are not stable. So on heating them, they are going to just lose one oxygen to give you KNO2 plus O2 or NaNO2 plus O2. This is the only thing different over here. So yeah, of course you need to balance it. So balancing will be like this. So this gives me that nitrate of potassium and sodium, when heated, they are going to form into nitrite. Nitrate to nitrite. Remember, language of chemistry. Oxygen more, 8. Oxygen less, 8. So nitrate converts to nitrite and oxygen is going to be given out. So this was how the decomposition takes place of potassium and sodium. Now we talk about the other ones. That is from calcium to copper. From calcium to copper, if you take the nitrates over here, they are just going to give me that, the nitrates of this will give me metallic nitrates, metallic oxides plus NO2 plus O2. So this is what is going to be given to me, that from Ca to Cu, it is going to give me metallic oxides plus nitrogen dioxide plus oxygen. So take an example. Let's take an example of Zn. So ZnNO3 twice is going to give me ZnO plus NO2 plus O2. Okay. This is how it is going to be taking place. You need to have a 2 over here and you need to balance it. So you can take this. It will be 2, then 2 and 4. Yeah. Zn2, N is 2 to 4, so 4 ho gaya. O is 6 into 2, 12. 2, 8, 9, 10, 11, 12. So you have 12. 8, 9, 10, 11, 12. Okay, so this is how you are going to see that zinc nitrate will give you zinc oxide plus nitrogen dioxide plus oxygen. Clear? So that is the nitrates when they are heated in case of potassium and sodium will be nitrite and oxygen. Whereas with other ones, it will be that particular oxide of the metal plus nitrogen dioxide plus oxygen. So what is the result over here? That nitrates when heated will give you nitrogen dioxide, and the color of nitrogen dioxide is reddish brown fumes. So reddish brown fumes will be seen when the nitrate is heated. Got it? So nitrate when heated will give you NO2 plus O2 as the gases which are given out. If you take Ag, again the same thing, Ag cannot, sorry, Hg ले लेंगे तो HgNO3 twice will give me Hg because it cannot suffice over here. So if it is, I take like Ag now. So AgNO3 is going to give me 2Ag plus NO2 plus O2. This is because sorry, Ag. So you get this because AgNO3 when it heated it will become AgO, but AgO is not stable. So Ag will become Ag plus O2. So Ag plus O2 के बदले आ जाएगा Ag plus NO2 plus O2. Okay, so that's why oxygen formed over here will be something more accordingly. So that's why you can see the balancing also. Here 4 NO2 is there, but it's only 1 NO2. So that's why because of this particular reason that AgNO3 से तुझे oxide नहीं मिलेगा. So accordingly we see that silver nitrate will give you silver instead of silver oxide. Clear? So this was the decomposition reaction or thermal decomposition reaction of some standard salts or standard material like oxides, hydroxides, carbonates and nitrates. To sum it up, oxides of most of them are stable, so they don't give you anything. Hydroxides of most of the substances except for K and Na, they are going to be unstable, and when they are going to react, it gives me a metallic hydroxide will give me metallic oxide plus water. In case of carbonates of potassium, sodium are stable, but all others are going to give me metallic oxide plus carbon dioxide. Whereas the nitrates all are unstable, so K and Na will give me a nitrite plus oxygen, where others will give me a metallic oxide plus nitrogen dioxide plus oxygen. Okay, so this was the decomposition reaction of some standard thermal decomposition reaction. There are some other heat related thermal decomposition, like the first one is the one which is the effect of heat on substances like ammonium dichromate. So let's go one by one. We can see the difference over here. Now certain things which are given over here are important because they are having a particular color change, and these are important questions for what is the observation for. Now see, all these questions what we saw over here are very good examples of when they ask you questions as write the observation for. Okay, so in the write the observation for, if there any kind of a color change or any kind of a gas evolved, then these become very important questions. So here the question over here is ammonium dichromate, that is NH4 ammonium dichromate Cr2O7. So sorry. So when this is heated, it is going to give me chromic oxide Cr2O3, okay, plus H2O plus N2. So this is what is going to be given to me when this is heated. Now over here, what is the importance over here? Importance over here is that ammonium dichromate is orange in color. Okay, it is an orange compound, whereas chromic oxide is green in color. So you can see that on reacting this, on heating a orange colored solution, orange colored kind of a compound, you are going to get a precipitate over here or leave a residue of greenic chromic oxide. Green color chromic oxide is going to be given out. So orange and green, important highlights over here. Similarly, the next thing will be CuSO4.5H2O. Now you remember that this thing over here is the water of crystallization. Water of crystallization is that particular amount of water which makes a particular kind of salt into a crystalline form. So this is water of crystallization. This is blue in color. So this complete crystalline form is blue in color, and when you are going to heat this, it is just going to become CuSO4 plus H2O, so 5H2O. Now this over here is white colored powder. So it is anhydrous white powder. So you see that on thermal dissociation, a blue colored crystal turns into white colored powder. But if I heat them strongly, so बहुत ज़्यादा heat किया इसको, तो CuSO4 on strong heating is going to give me CuO plus 2SO2 plus O2. So Sulfates are going to give me sulfur dioxide as the thermal decomposition. So here is a new reaction which is not there in the earlier part. Sulfates were not taken into consideration because this is slightly different. So that's why copper sulfate, if it is crystalline and heated, it becomes white. If this white is heated strongly, it is going to give you copper oxide. Now copper oxide over here is black. This is white. White color के बदले हो जाता है black color. The next is thermal decomposition. Now thermal dissociation. It is a decomposition reaction in which substance dissociates into two or more simpler substances on application of heat. So when one compound is giving rise to two separate compounds is called as thermal dissociation. So thermal dissociation के examples में the first one is if you take ammonium chloride. So if I take over here NH4Cl on thermal dissociation, it's a reversible reaction, forms into NH3 plus HCl. So NH3 plus HCl gives you NH4Cl. NH4Cl on heating gives you NH3 plus HCl. So it's a thermal dissociation. Why dissociation? Because two compounds are going to be formed by one single compound. So dissociation of the thermal dissociation of ammonium chloride. Similarly, it is also going to be N2O4 on heating is going to be N2 plus it is 2NO2. So this is thermal decomposition of dinitrogen tetraoxide. Dinitrogen tetra. 4 is tetra. So tetraoxide. So that's the thermal, which is also a reversible reaction. Then there are certain which are electrolytic decomposition. Electrolytic decomposition are the ones in which when electricity is passed through it, then only it splits into two. That's why we have over here H2O splitting into H plus and the H2 plus O2. So this is a electrolytic. So electric current is passed through it. It is electric current. This was heat, whereas this is electric current. So this is nothing but electrolytic. Electrolytic decomposition. So electrolytic decomposition may we are applying electricity to a compound, and on applying the electricity it splits into two parts, that is H2 plus O2. Similarly, if something can dissociate by just the presence of light, it is called as photochemical decomposition. This Photochemical will be one which is related to light. So if light falls on it, lights fall on this. So this will be 2AgCl giving me Ag plus Cl2. This is example of the photochemical decomposition. And then could be decomposition reaction in metallurgy. Now this, one sec. Yeah, we'll quickly go through this also. That is, see, in case of metallurgy, what happens is you are going to have the compounds which are present. Metallurgy is nothing but extraction of the metal from the ore of it, यानी minerals में से, यानी soil में से. अभी soil में उन लोग जब भी रहते हैं तो they are not in a single form कि oh this is only pure zinc, this is pure this kind of sodium and all. They will always be in the form of carbonates and sulfates and things like that. So in such cases, you are going to use those carbonates को heating का method या तो nitrates को heating का method, and you are going to generate a kind of, so that's why you will always have, suppose I have got zinc carbonate over here. So what I am going to do, I am just going to heat it to make it ZnO plus CO2. So hence I am going to use such kind of a method to break down that particular compound into smaller paste, so that अभी मुझे क्या करना है, सिर्फ उसमें से इसमें ऑक्सीजन निकालना है. अगर मैं ऑक्सीजन निकाल दूं तो automatically this becomes a pure zinc. So here, what in case of a decomposition reaction in metallurgy, an important step is extraction of metal from its ore is to convert the concentrated ore into its oxide. So converting the concentrated ore into its oxide is a very important reaction, which is called here it is called as calcination. The concentrated carbonate ore is heated in limited supply of air at a temperature not sufficient to melt the ore, and the process converts the ore into an oxide which is easy to reduce. Then I just need to reduce by removing the oxygen, and by a reducing agent I can just take a reducing agent and I can remove the oxygen later on. So but the main thing over here, this is called as calcination, which is a kind of decomposition reaction used in metallurgy. So this was our second part over here, which was the method was decomposition reaction. So we learned synthesis reaction first and now the decomposition reaction. The next will be the next video next time.